So I'm going to be going through my flashcards that I have so far, my first month of actually getting into astronomy a little more seriously, like studying it and stuff. I thought this would be a cute format to share my information with the world / literally just myself. I don't think I'm ever going to open this to the public. I don't know. We'll see. It's just, I don't know. Well, yeah, we'll see. So this is how I keep my flashcards, and then I have a little, you can't really see it that well because it's so close, but you see? It's very cute. So I picked these ones specifically, and then some other ones will be in other videos, because like the Voyager 1, the Golden Record, Kepler 186, just specific things like that. Like I kind of would want to get into a little more detail. So I'm just going to do some random ones that I decided to pick out. So asteroid versus comet. Asteroids are made up of metals and rocky material, while comets are made up of ice, rocky material, and dust. So asteroids are formed closer to the sun where it was too warm for ices to remain solid. So asteroids forming closer to the sun doesn't have any problems since they are just made up of metals and rocky material. Whereas comets are formed farther from the sun where ices would not melt, so it didn't have to worry about that. This is why comets appear to have a tail as the ice melts the closer it gets to us, because we are close to the sun, relatively. Both were formed early in the solar system, about 4.5 billion years ago. Very interesting. And then this kind of goes hand in hand with what I just wrote or read. Shooting stars are not actually stars. They are small pieces of rock or dust that hit the Earth's atmosphere from space. It moves so fast that it heats up and glows as it's pulled in by our gravity. They're actually called meteors, and most burn up before they reach the ground, and the ones that do are called meteorites. And since the Earth, oh my god, I was blurry. Okay. And since the Earth is 75 or 70% made up of water, most meteorites fall into the sea. So that's kind of interesting to think about, that our oceans very likely have a ton of space dust and rock just in them. I guess now they're just rock and maybe sand. I don't really know what happens to them once they're in, like, does salty water do anything to that? That is something to look into. Actually, I'm going to write that down. Well, I have my iPad here, so I'm just gonna, what happens to meteorites when they fall into the ocean? Like, have we studied that at all? They instantly cool, often shatter due to the intense impact force, and sink to the seafloor. Yeah, this will have to be something I like more look into, but isn't that interesting? So cool to think about that there's just a ton of material, rocky material, like just in, it's so cool. Anyway, pulsars, this is interesting. They're similar to quasars, but not quite, since they are not supermassive black holes. They are stars, specifically rapidly spinning neutron stars, about 700 times per second, that have beams of electromagnetic radiation, including radio waves, X-rays, and gamma rays from their magnetic poles, like a lighthouse. Very interesting. I can't really describe like what it looks like. I mean, it's just like a bright star, super bright, very dense, with two just like beams of light. And it's shaking rapidly and also spinning really fast. So it's kind of intense, but very, very cool. I think they're awesome. Not as cool as quasars though. Quasars are definitely my favorite so far. Universe thing out there. How are stars formed? Now this one I want to look a little bit more into and actually like word it in a way that's better understood. But I'm just going to read off what I have here. This is just a card that I made early into my little journey, so I wasn't really putting things into my own words or fully understanding like how to source things. So stars form from massive cold clouds of gas and dust that collapse under their own gravity, triggered by disturbances like shock waves. It then heats up, forming a protostar, which eventually becomes a true star when its core gets hot and dense enough for nuclear fusion to start. See, it doesn't, I don't know. I feel like I could definitely tweak this one a little bit more. And I'm going to put it off to the side, actually. Ooh, this one's interesting. So the middle star of the Big Dipper, you can see the Big Dipper here in this little diagram. The middle star of the handle is actually not just one star, it is two stars. It's not just two stars, it's actually math 6 stars. But let's start with the two. Alcor and Mizar is what they're named, and Alcor is slightly higher than Mizar, and these names translated directly from Arabic mean rider and horse. Alcor meaning rider, the one that's slightly above, and then Mizar being horse. Isn't that cute? That's so cute to me. Yeah, I think that's so cute. And Mizar itself, the horse, is actually a quad star cluster. So 4 stars orbiting each other. Very interesting. Just a fun little fact. Exoplanets, I'm going to try to remember this one without looking at the card. Exoplanets are just any planets that are outside of our solar system. They usually are rotating a star, and the ones that aren't are called rogue planets. And there are more planets in the universe than stars. It's theorized, I'm pretty sure. I don't know how they figure all this out, by the way. That's like a whole nother thing, but let's see. There are more planets. Let's go, rogue planets outside our solar system. That one's easy, but pretty cool. Kepler 186f. I will get into her now, actually. Kepler 186f is known as the cousin to our planet, and I'm actually going to try to remember some of the facts without looking at it. Here, I'll put it there so you don't know I'm cheating. Why am I talking to this like it's actually going to be like a thing that people are going to watch? I'm planning for just myself to like look back at this and okay, whatever. I just think it's cute. I think it's fun. So the Kepler 186 is known as the cousin to Earth because it is not that far away. It's around 500 light years away, which is not a lot in comparison to the entire universe and how expansive it is. It's in the Goldilocks zone. It's in the habitable zone, just like we are with our star, where it's not too hot, not too cold. It is orbiting a red dwarf star, which means that if there is plant life, which is highly likely, on Kepler, it could change the photosynthesis and make it look red. I don't know. Hold on. Make the plant life look red, which is interesting. I didn't know that was a thing. So you got 500 light years from Earth, habitable zone. 10% larger than Earth, which is around the same size. It's really not that much of a difference. Their year is 130 days rather than 365. And the red dwarf star may influence the plant life, make them red in appearance. Something with photosynthesis. I don't know all about that yet. Keyword yet. I want to get into like plant stuff and like fungi and all that. Quasars! Quasars! Quasars are my favorite. They're so cool. Quasars are giant... Pause. Background has been disturbed. Got a little too excited about quasars. Ah! Okay. Quasars are sick. So there are supermassive black holes. Supermassive black holes. They are one of the most powerful things in the entire universe. Gas and dust spiral into the accretion disk in the black hole. This heats up and releases energy in the form of electromagnetic radiation. The electromagnetic radiation then creates plasma, which is ionized gas, and it's jet time. Jet, two sides just like the pulsar star, but again, this is a supermassive black hole that gets super duper duper hot. Electromagnetic radiation creates plasma. Then the plasma jets shoot from both sides and can blast out thousands of light years, and are powerful enough, get this, to destroy an entire galaxy. Whoa, we are one of those. We are in a galaxy. That's crazy. Brightness of 1 trillion stars. What? Closest quasar to us about 600 million light years away. And most of them are dead by now. I think that was the thing. Or they were more popular when the universe was like first created. Again, don't ask me how they figure all this out. I'm not there yet. Circumpolar stars. Circumpolar stars are the stars around the Polaris, which is the North Star, that never set. Because if we know North Star, it kind of is just up there, and it kind of stays in the same spot. And everything kind of like rotates around it, but it's not rotating. We're rotating. But that's really it. Good vocab word to know. Sirius is awesome, but I do feel like I need to revise this card. 8.6 light years away, has a little buddy following it called Sirius B, a white dwarf star. See, I didn't even write what kind of star Sirius was. And I said it twinkles so intensely because it is so close to our horizon. Now, what does that mean? I don't know, because I didn't write it down. I didn't write anything else down, so there's space on this card, so I'm gonna revise that, put that in the revise pile. Polaris, also known as the North Star. If you had to guess, top 10 brightest star? Nah. Top 20? No. Top 30? No. Top 40? No. It's actually the 49th brightest star. It is 433 light years away. It's a yellow-white supergiant. It's actually 3 stars orbiting each other. And then, again, could possibly put more fun facts here because people think it's interesting. So I would like to just be able to be like, info dump. Oort cloud time. Oort cloud is actually crazy because no one talks about it, and it's the largest part of our solar system. It's a giant sphere of rock and ice surrounding our solar system. So it takes the sun 8 minutes and 30 seconds, I think, to reach us, for the light to reach us. Which we're pretty far, but we're also very close, again, relative to everything. It takes the sun, remember, light, very fast. Light is very, very, very fast. 1.5 years to reach the outer edge of the cloud. 1.5 years? Bruh, that's crazy. Like, that's crazy. Also, the Voyager 1 that was sent out in 1977, I believe? Somewhere in the 1970s. So it's been going super fast for so long. It's gonna take it centuries. It's gonna take it around 30,000 years to get through the Oort cloud, and obviously by then we will be pretty much long gone, especially with how the world is going. So just very interesting. And the gold record that we put on there. I do need to learn the difference between Voyager 1 and Voyager 2 because there are very different things and I do get them mixed up sometimes. Let's see. A super void. This is one I also need to revise. But it's basically a huge, nearly empty region in space that contains fewer galaxies, galaxy clusters, and matter, and we are likely in the KBC super void. Very interesting. Very interesting. Again, I don't know how they figured that out, but we might be. And in super voids, matter can be a certain percent thinner. I forgot what this percent is. But in the KBC super void, they predict it is about 20% thinner. So that's why it takes things so long to get to us. That's like that's their theory. They're just like, I don't know. Andromeda Galaxy, this kind of gets into that a little bit. So the Andromeda Galaxy is one of the few galaxies that we can actually see from Earth with our naked eye, just looking up. It's very faint. And honestly, I still can't really locate it without using my Starguide app. It's also known as the Messier, I'm probably pronouncing that wrong, but Messier 31 or M31. It is a spiral galaxy at about 2.5 million light years away, which is really close, again, in comparison of stuff. But what's super crazy is that if there is, which likely there is, life over there, they don't know we exist. Our light has not reached them yet. What? And it's also probably dead by now. Like, the light that we see is probably, it's gone. 2.5 million light years away! That's so crazy. Okay, it's roughly 220,000 light years across, which is about twice the size of our Milky Way galaxy. It is estimated to host about 1 trillion stars, which is a lot more than us, moving at approximately 100 kilometers per second, which I need to actually look up the, let me see. How fast is the Andromeda Galaxy moving towards us? 68 miles per second. Wait, that's so cute. They've come up with a name for when we combine into an elliptical galaxy. Milkomeda? Guys, come on. They just said Milky Way Galaxy and Andromeda. Milkomeda, bruh. Will humans survive the Andromeda? Okay, so my phone just died. Okay, so my phone just died, and then in that time that I was waiting for my phone to charge, I decided that I'm going to post this on YouTube, so you'll be seeing this on YouTube, on a different account. If you recognize my voice from my main account, that is fine. I'm not embarrassed. I was like, should I change my voice? Like, what do I... Girl, it's not that serious. Like, literally what we're talking about, like, we're just a floating speck in space. Like, it's not that serious if someone, ties me to my account where I, like, show my face and stuff. I don't know. And I would show my face on this account. It's just not going to be the focus of it. So, yeah. Anyway, we were talking about the Andromeda Galaxy. Roughly around 220,000 light years away, about twice the size, blah, blah, blah. Oh yeah, and that eventually, like, it is just, like, moving towards us, pretty quickly, but kind of slow for how far away it is. And it will collide with us, and I guess apparently be called the Milkomeda Galaxy. Guys, we can come up with something a little better. We got a lot of time, about 4 billion years. So that's pretty cool. Andromeda Galaxy, she's beautiful. How are planets formed? Planets are formed starting with a nebulae which is different than a nebula. A nebula is just one cloud of gas and dust, and a nebulae is multiple. So starts with a nebulae. Part of that is gas and dust, and the gas contains hydrogen, helium, and carbon, which then ties into my last card about us being stardust. But when the nebulae becomes dense enough, its gravity starts pulling itself together. It starts heating up, and when it gets dense and hot enough, the atoms start to fuse, called nuclear fusion, which you've heard before. Goddamn, can I just get this video without getting interrupted? I just got a timer about turning my heater on because it gets really cold in here and I need a reminder to turn it on before it gets freezing. It starts heating up, speaking of, and when it gets dense and hot enough, the atoms start to fuse, called nuclear fusion. As the disk rotates, which, like, that's what it is inside of, it's now forming a disk, the material in it lump together and get bigger. It's called accretion. Accretion. Is basically just like a bunch of little, like, so it's gas, dust, rock, just bunch of matter sticks to each other, and it gets big, and gravity gets big, and more deads and hotter, and then it just becomes a planet. It's very interesting. And then there's like a whole another thing, and it depends on the planet, on like what kind of planet it ends up actually being. If it's like Jupiter, Uranus, like all the different kinds, like there's so many different kinds of planets, it's actually insane, but we're not gonna get into that right now. And then my last card, we are stardust. We are stardust, and that is it. We are literally just stardust. And I realized that this exact theory, it's not even a theory, it's just it's proven, is the reason that I feel the most comfortable with the idea of reincarnation. And now I've never thought of it as the traditional like version of reincarnation, where it's like, oh, someone could come back, I'm gonna come back as a snail, I'm gonna come back as a bird, I'm gonna come back as a rock. But technically, yeah, like technically, because matter cannot be created nor destroyed, everything there has ever been and will be was and is. Does that make sense? Okay, I'm just gonna read the card. Stars that go supernova, meaning they explode powerfully, are responsible for creating many elements of the periodic table, including those that make up the human body. There's actually a list. I don't know why it's not on this card. I thought I wrote it down on here, but I guess I didn't. Where is it? I gotta go into my history. Okay. Okay. Oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus, potassium, sulfur, sodium, chlorine, and magnesium. Whoa. Whoa, guys. Okay, I found it. It's oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus, potassium, sulfur, sodium, chlorine, and magnesium. With trace elements, which means less than 1%, is boron, chromium, cobalt, copper, fluorine, iodine, iron, manganese, molybdenum, I've never seen that before, selenium, silicon, tin, vanadium, and zinc. Insane, right? And as we know, yeah, matter cannot be created nor destroyed. So when the universe began, whenever that was, I personally Guys, give me a second. Okay. I personally kind of don't believe in, like, yeah, the Big Bang Theory, sure. Like, it all had to happen at one point, I guess. But saying that, like, the universe itself is 14 billion years old, I don't believe in that. I think it's just incomprehensible how old the universe is. It's there. And then we get into the, whoa, what created it? Girl, it's just there. I don't know, sometimes it's just, like, there. Like, I don't know. That's how I feel in this moment. January 24th, 2025. Nope, 2026. That's how I feel in this moment. Yeah. So that's the video. And I guess I'm making YouTube videos now here. There's no upload schedule at all. There's no expectation of me actually uploading here. I feel like this is going to be very niche part of, I don't know, the just YouTube in general. I don't see a lot of people watching this, and that's not really the point anyway. But it would be interesting if, like, a little community started here. Like, that'd be kind of fun. We can talk about space and LPS and paleontology. That is my next topic that I really, really want to get into, and then I eventually really want to get into history. I just want to learn everything. I proved to myself that I actually can learn hard things, and I can think about things that I thought I wasn't smart enough for. But doubting ourselves is not cool anymore. It's not cool. Loving ourselves and pushing ourselves is actually really dope. So yeah. I guess I should have, like, an outro or something. Okay. Wait, I was gonna have her, like, or me. This is me. I am talking. What do you mean? Also, oh, my name is Opaline. Opaline. I said my own name wrong. Opal for short. The character. This is the character. My name is, I don't know if I want to give my name on this platform yet, but yummy in my tummy. Okay. What was that? Thanks for watching, I guess. Bye. That's gonna be an outro, I guess.